Okay, good morning, everyone. Questions before we get going? Any questions? Okay, so before I move on to chapter 3, I would like to ask you a few questions about what we did last time, and then I move on. So last time we introduced the idea of exponent, and let me see how much you remember. So suppose I have a is a number. What does a to minus n mean? Quickly, I like the answers on chat. When you see a negative exponent, what does this mean? Please, what does a negative exponent? Thanks. It's 1 over a to the n. What does a fractional exponent, 1 over n, means? Again, anybody? Okay, when you have 1 over n, not minus n, that's the nth root of a. Okay, and finally, what does a to the m over n mean? So when you see something like that, what does it mean to you? I mean, it has to have, we have to know what those mean. Okay, anybody again would like to write it on chat? Okay, denominator is the root a. You can put m inside, or, and this is a lot of time, this one is sometimes easier, which is the same thing as doing this. All right, so that's really those definitions. So I'm gonna look very quickly at the questions that I've assigned number 3. I'm gonna pick some of the problems, and I want you, all of you, not only one of you, to on chat to tell me what the answer should be. So the question is, rewrite the following expression so that they do not contain negative or fractional exponent, but do not simplify your answer. So the goal is to make sure you understand the notation, not really to give me the answer. So 4 to the minus 1, rewrite so there is no negative exponent. That's really the idea. So please quickly, I want all of you to do that. If you guys ever gonna do calculus, oh boy, if you don't know that, you're in trouble. All right, so I'll start asking student then. If you guys don't want to answer. Aiden, what shall I write?
Is this the one when you like turn it into a fraction?
Yeah, what is the fraction?
1/4.
Yeah,
Or
1 over 4. Okay. Aiden, stay with me. Then I move away from you. Minus a to the 2/3.
Sorry, I'm getting a phone call from my mom.
All right, so you answer her. Ricky. Minus a to 1/3, rewrite so there is no fractional exponent here. So it means I want you to rewrite using those roots idea. I don't want the answer. I just want a rewrite. Ready? Okay, so the denominator is the root, cubic root. This is minus 8, thanks Taylor, and the whole thing to the power 2. That's what we mean by rewrite. So that's exactly what we mean by rewrite. Now, if I ask you to simplify your answer, so if I tell you just to rewrite, you stop right there. If I tell you simplify, you have to go one step further. Cubic root of minus 8 is minus 2 squared, which is 4. But that's what we mean by rewrite. That's really the important part. All right, so I will take 3 more and then I proceed. This one is a little bit harder, but 2/3 to the -1. First, I want it to be rewritten and then simplified. So if nobody put anything on chat, I will pick one of you. So first rewrite so that no negative exponent remain, and then we're going to simplify. But it's rewriting that I care about now. Kale Schwark, are you with me? Kale? I tried to pronounce your name correctly. I don't know. Kale?
Yeah. Would that be 1/2?
Yeah, don't be afraid. 1/2. That's really what it means to the -1. It's 1/2. That's the rewrite. Now, how would you simplify it? Stay with me. Now simplify. 1 divided by that. Give you what? Property of fraction. What does it? How do you do that? You're with me, Kale, right?
Yeah. Two.
How do you divide fraction? That's the 1 divided by 2/3. How do you divide fraction? It's 1, thanks Isabel, multiplied by what? By the reciprocal of that, which is equal to 3/2. Are you with me now?
Mm-hmm.
Okay, I'm going to give you another one along those lines, and I want all of you to do it. I'm actually picking problem for the homework that I gave you. 2/3 to the -2. First, I want the rewrite, and then I want the simplification. All right, I give you all a minute to do it, and then I will pick one of you and you proceed. In the meantime, those who got the answers of the rewrite, put it on chat. Be very careful. No, the answer I have it is not correct. Be very careful. Very careful. No, no, you're all doing the same mistake. Go over the definition carefully. So this is the power and this is minus. Okay, I'm getting one correct answer, I think. Right, so it is, watch carefully for those who got it correct, wrong. It's 1 over whatever you have to the power 2. Don't play with the 2 the way you want. This is the -2 go down. So it's 1 over 2/3 to the +2. That's what we mean by rewriting. All right. Now we're going to simplify it a little bit, but first that's the rewrite. That's the part when I tell you rewrite, that's what I want. I want to make sure you understand this picture. Now we're going to simplify it. Okay, again, I'll give you a minute to see if you guys can simplify it and put your answers on chat. Please, all of you do it. All of you is responsible. No, no. Okay, that's better. So, Nick, would you like to talk?
Yeah.
Okay, tell me what you did.
So I don't know what order you did this in, but you could do the exponent first, I guess. So you could do 2 to the second power, which would be 4, and then 3 to the second power, which can be 9.
Very good. So it's 2 square over 3 square.
Mm-hmm.
Okay, absolutely correct. Because what is 2 over 3? Square. So basically, it's what it's 2 times 3 multiplied by 2 times 3. It means when you multiply fraction, you multiply numerator over product of the denominator. That's exactly what he's doing. Okay, now he rewrite it, basically. Now his simplification, 1 over 4 over 9. And then property of fraction times 9 over 4. Absolutely correct. Okay. I will do one more along those lines, and I urge you to do every problem in number 3. Right, so let me do one more. I'm just going to pick them arbitrarily. 16 to the minus a half. Again, first rewrite, so no negative power and no fractional power remain. Actually, we may need 2 steps here. And the end we simplify. But first I want to rewrite. No, 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 no. Right, yeah. Watch carefully. This is playing the role of n. This is basically the power. Since I have minus, it means that it's 1 over 16. This minus, you turn it into plus to the power a half. Okay, whatever here, so 1 over 16, the minus turned into a positive. This will become a half. Now we're done. I don't want fractional exponent. It means this is exactly the square root of 16, which is 1 over 4. That's the simplification. Okay, that's how I want you to move. So that's the rewrite. I don't want fractional. That's the square root. Then it will become 1 over 4. Okay, the last one. The last one is, since you're messing up with this minus, I'm going to pick another one. Where's the minus? So 8 to the minus 4/3, which is j in this problem. So I'm really doing number 15. First, rewrite. And this time there will be 2 rewrite. Rewrite, and the simplification is the last step. But first, I want the rewrite. Right. So my first is 1 over 8 minus 4/3 will become 4/3 when I move it to the denominator. Step number 1. Correct. Now step number 2, I don't want fractional. So now I want you to introduce the root. So what will this become using the root? Because I want to evaluate it eventually. So if I want to use the root, what this would be? What's going to go here? What should go here? Which root this is? That's the cubic root of 8 to the power 4. Now we can understand it. Now we fully have an understanding of what this expression is. And now I will get cubic root of, this is it, 2 to the power 4, 1 over 60. Okay, that's the simplification. But that's really what I am after right now, so you understand this notation. Okay. Now, the last thing I want to do before I move on to the in section 3.1, and we have a lot to talk about in this section. Today, it will be a lot of talking. So my question now is along the same lines of those exponents. My question is, I'm going to introduce an unknown, call it R. And my question to you is, find R. So very simple. I'm going to root 1 over 2 square is 2 to the R. I'm going to rewrite it like this. I'm going to reverse the process. What is R? So if I write 1 over 2 square as 2 to the R, what is R? I mean, what should be this exponent right here? Okay, I'll do the first one. So I give you a head start. What do I mean by that? This R should be -2. That's what I mean. Because 2 to the -2 is by definition 1 over 2 squared. All right, so that's really what I mean by finding the R. So if I rewrite 1 over 2 squared as 2 to a power, what should be this power? Okay, based on what we did, this power has to be -2. That's the type of question I'm going to ask. So suppose I write A is a number. I write 1 over x cubed is x to the R. What should be the R? Okay. Taylor, what do you think? Taylor, can you hear me? Yeah, my R should be exactly -3. So that's how we're moving. Now I'm going to give you others. 1 over the square root of x is x to the R. What is the R? Yep, don't be afraid. You're right. Exactly. Its R is -1/2 because 1 over root x is basically 1 over x to the power 1/2, which is x to the -1/2. So we're actually moving backward because you have to know backward, forward. That's as simple as that. Okay, 2 more. Cubic root of x. Is x to the R. What is the R? Again, I'm waiting for answers. Cubic root of x, x to the R. What is the R? Olivia, do you have any idea? Olivia, are you with me?
Yeah, I'm with you.
Do you know what the R is?
I'm not really sure about this one.
Okay, remember, you have to, basically, you have always to keep this in front of you. Okay? Nth root of A, if you have the root here, is A to the power 1 over the root. Okay, keep this in front of you, and on bright space, I gave you a worksheet. I gave you a summary of all the exponents. Please print it and have it with you. So here the R is 1/3. Okay, because x to the 1/3 is what we mean by the cubic root of x. Okay, I'll give you one more, and Olivia, give it your best shot this time. What if I do cubic root of x squared? It is x to the R. What is R?
Would that just be x to the power 2/3.
Absolutely. R will be 2/3. Okay. So just keep it in front of you till you internalize it. So it becomes something that you know without looking. Okay, my last one is, suppose I give you 1/, I don't know, 4th root of x. It's x to the r, actually 4th root of x cubed, just to make it a little bit harder, not much. What's the r? So you can do a little bit of math. I mean, you don't have to immediately figure it out. Just go here and start, write it up, blah, blah, blah. I don't know. You do it. And put your answers on chat. Yep, yep. Anybody else? Yeah, correct. This right here, this would become, this is the denominator is the root and the power is the numerator. So 1/x to the 3/4, it means x to the minus 3/4. So r here is minus 3/4, right? Okay, so please go over those problems by yourself again at home till slowly you internalize those exponents. For those who will do calculus, I don't know who among you will do calculus, this will be extremely important. You will not be able to do it without knowing those kind of exponents. Right. Today we're going to move on to section 3.1. And we're going to talk about something called exponential function. So I'm going to be doing a little bit more talking than usual, so you bear it with me. So section 3.1, exponential function. Okay. So far we studied two types of function, linear, quadratic, and we talked also about something called piecewise defined. But the basic two functions we studied are linear, that have the form mx plus b, quadratic, that has the form ax squared plus bx plus c. Today we're going to introduce a new type of function called exponential function. First, what does an exponential function mean? What's the shape of, what's the form of it? So definition. Okay. An exponential function is a function of the form. So that's the form it has. So what do I mean? Like a form, like linear, it's mx plus b. That's its form. Quadratic is ax squared plus bx plus c. Now exponential is a function that has the following form. F of x equal a times b to the power x, okay, where a and b are constant, a not 0, and b has to be a positive number. Okay. Now let us note something let's note something important here is that the independent variable or the input, the x value if you want, is an exponent. Means the x here is an exponent. Thus the word exponential. So it's called exponential because the x is an exponent. So immediately example, so you can visualize or at least see what type of function we're talking about. So example, f of x equal 4 times 3 to the x. Okay, and that's, the book put dot to tell you it's a multiplication. So I'm going to use times to tell you multiplication. So there will be no, You understand the notation. So that's a typical exponential function. A in this scenario is this constant term. That's my A. And B, sometimes called the base, and is the 3. So that's the shape of it. Now let us evaluate this function for few value of x so that you will see how it works. So we're going to just evaluate for some value of x. So suppose I'm going to evaluate what is f of 0. What is f of 0? It's 4 times 3 to the power 0. So the x is a power. Now, anything to the power 0 is 1. This is equal to 4. So A usually is the output when the input is 0. And we're going to call A the initial value, because if you're going to graph this function, f of 0 is 4, which will be usually the 8. Okay. Now let us evaluate other values. Suppose I compute f of 1. It's 4 times 3 to the power 1, which is 12. So at 1, the function takes the value 12. Okay. So somewhere like this. Now let me evaluate f of minus 1. And that's why we introduced negative exponent before. It's 4 times 3 to the minus 1. Okay, that was the main reason I had to introduce negative exponent. So what does this mean? 3 to the minus 1 means what? Quickly. Quickly. On chat. What?
It'll be 4 times 1/3.
Right, it's 4 times 1/3. That's why we had to start evaluating those negative exponents. So at minus 1, my function is somewhere here because it's 4/3. Okay, I will compute one value more just to make sure we f of minus 2. It's 4 times 3 to the negative 2. So now we're making sense out of this function because we studied those exponents. It means 1 over 3 squared, which is 4 over 9. 4 over 9 is somewhere in here. So if I keep going and I sketch all the value, I'm going to have some type of a graph that looks like that. So this is how we evaluate. So the unknown is important, is the exponent, is the power. That's hence the word exponential. So more example of exponential, just the form of it, no more evaluating. Another example, I can take f of x to be like something like 3 times 1.06 to the power x. In this case, the a is the 3. The b is the 1.06. That's what we mean by the b. Another example. Suppose f of x equal, I don't know, 8 times a half to the x. What is the a and what's the b? Quickly on chat. Let's play the role of a here. A is 8. The b is the base, it's a half. Okay. Now a have a special name. Not a special name. Actually, a, the name for a reflect what a, so suppose f of x equal an exponential. Then we have to note that f of 0, the output as 0, it's a times b to the 0. Anything to the power 0 is equal to a. So a is the output when the input is 0. So a is called the initial value because it's the value when x is 0. So a is called the initial value. B, and that's the new word, we're going to introduce two words today that we're going to try to understand. B has a name, it's called growth growth, factor. Okay, that's a new word. The initial value is a natural name because that's the value at 0. B will be called the growth factor. That's the name we give to B. Now, why do we study exponential? What type of real life problems will lend themselves into an equation that has this form or that has this form? And what type of problems would really lend themselves to that? The type of problem is the following. Let us say you get a job and you get this nice job. You start like at 40,000. It's not really much money. But then the company would tell you, I will give you, if you do a good work, of course, I will give you a 6% raise every year. Okay, every year, I will give you a 6% raise. So you start at 40. After 1 year, I'll give you 6% on your income. So your income is going to increase. The next year, I'm going to give you a 6% on your new income. Then I'm going to give you a 6% on your new income. So if you have a quantity that's growing by the same percent every year. So my question is, all right, how much will I make after 2 years? If the company keep my 6%, how much will I make after 5 years? How much will I make after 10 years if I stay with the company? What's the formula that will allow me to find how much will I make after T years in general if my money keeps growing, if my salary keeps growing at 6% every year? That's the problem we're going to work with. And that's where exponential function actually will come up. So I'm going to start with a preliminaries, and then I will build up the whole theory. So the question is, how do exponential function arise? In real life, how do they arise? And they arise a lot. All right, so preliminary. Suppose a person is hired at a salary of $40,000 and receives a 6% raise after 1 year. Okay, it's a very simple question, but it's crucial for the rest. 6% raise, so you get a percentage. Find his or her income, my apology. Find his or her income after 1 year. All right, so we're gonna do this problem in 2 ways. So income after 1 year. Okay, now how would you do this problem? So the raise is 6%. It means 6 over 100. That's what 6% is, which is 0.06. So what's the income after 1 year? I think all of you should be able to give me the answers. Pick up your calculator and give me quick answers. Okay, anybody? How would you compute the income after 1 year? So his starting salary 40. After 1 year, he got a raise of 6%. What is his new income? 40,400. All right, so what's the income? It's 40,000. That's his old income plus 6% of his income. Now, how do we compute 6%? We multiply 0.06 times 40,000. Okay, so that's really the basic, all right? So which can give me, your classmate, and I believe him, 42,400. Okay, so income after 1 year is 42,400. So that's his old income plus 0.06 times that, which is going to give me that much. Now, another way we can compute the income. Another way. So another way to find the income. I call it the new income, to find the new income. the new income. It means income after 1 year. Okay, let's compute the new income in a slightly different way. What's his new income? And now listen to me very carefully. It's his old income plus 6% of his old income. So it's his old income, and watch how I'm gonna write this. It's his old income, it means 100% of his old income plus 6% of 40,000. That's his new income. So his old income, 100% of it, all of it, but you're adding to it the 6%. So what percent of his new income he's gonna have? It's 100%. We're adding to it the 6%. So his new income is going to be 106% of 40,000. Where is the 106% coming from? It's the 100% plus the 6%. So what's 106%? It's 106 divided by 100. It means 1.06. All right, so his new income is going to be 106% of that. It means 1.06 times the 40,000. Okay, or I'm going to switch them around, or it's 40,000 times 1.06. Now, if you plug in this into your calculator, of course, you're going to get the 42,000. Now, definitely, will give you exactly 42,400. But I need this format to build up the course, to build up this whole chapter. So after his new income, it means after 1 year, what he will be making. His old income, whatever it was, you times it with 1.06. So this is the old income times 1.06. Where is this 1.06 coming from? It's the 100% plus the 6%. It's 106% of his income. Okay, before I move on, any questions about that? Any questions? Very good. So now we're going to move to the first scenario in this course, in this chapter. Now consider the following scenario. So I'm going to call it scenario 1. Scenario 1. A person is hired at a salary of 40,000 and receives a 6% raise each year. Let f of t the income after t years, which means t years after he is hired. It means t years after he's hired, after the person is hired. Okay. Now I want you to find f of 0, f of 1, and f of 2, and you're going to find it in a way that we can head to a general formula. What is f of 0? It means f of 0 will be the income 0 years after the person is hired. So f of 0 is going to be how much? Please, back to you. So he's hired at 40,000. F of t is his income t years after he's hired. What is f of 0? 40,000. Okay. What is f of 1? F of 1 is his income 1 year after he's hired. Now we just did it a minute ago. It's 42,400. I agree with you. But what is f of 1? How did we get to 42,000? 2 ways. The first way is the way your classmate is, and the second way was like that. It's the 40,000. What did you times it by? 1.06. Where does 1.06 come from? It's the 100% plus the 6%. So it is gonna give me 42,400. Sorry, $42,400. How much is gonna make after 2 years? Okay, I'll give you a minute, all of you, to give me the answer. Okay, Ricky gave me one. Anybody agree with him? I'm not doing the math, so I need two similar answers to agree with you. How much you're gonna be making after 2 years? Okay, there is a disagreement. I'm having 44,800 and I'm having another one. I don't know which one is correct. I want one more answer. I want one more answer. Okay, so, all right. And I'm gonna do this problem in 2 ways. Watch carefully how I'm gonna do it. The first way I say, okay, after 1 year, he got another 66%. So his income is gonna be his old income plus the 6% of his old income. Now, if I pick up my calculator, I'm getting 44,944. All right? So that's one way to do it. What he made plus the 6%. So that's how much his income is. It increased by 6%. Another way I'm going to do this problem, I said, you know, instead of doing 2 operations, I can do this in one. Or it's his old income times what? Times what? What should I multiply this by? What should I multiply this by to get his new income? I stop right there. Exactly. I should multiply it by 1.06. Okay, so you can do this problem 2 ways, and that's the one I realize I'm emphasizing. I multiply it by 1.06, and then I get exactly 44,944. So I multiply his old income by 1.06, which is the 100% plus the 6%, and I get that much. Okay, question number 2. I want to find a formula for f of t. It means instead of doing it after 1 year, 2 years, 3 years, 4 years, forever, my question number 2 is find a formula. It's the same problem. I'm not really changing, but find a formula for f of t. So question number 2 is find a formula for f of t. So in general, what's going to be the formula? For f of t. All right, I'm going to make a table and we're going to build it. So I find a formula for f of t, or find the income after t years. That's really what the formula, find the income after t years. Okay. I'm going to make a table and you guys will have to help me out to see the picture. If you understand this table, we are doing fine. So this is t, and this is f of t. Okay. At t equal to 0 means initially it was 40,000. Right? After 1 year, what was his income? Now, I'm not going to put numbers because we know how to plug in numbers into the calculator. What was his income? It was the 40,000 times 1.06. That was his income after 1 year. It means from here to here, I'd multiplied by 1.06. That's how I got his income. That's the 100% plus the 6%. What was his income after 2 years? So now this is his income the year before. So what's going to be his income after 2 years? It's going to be exactly what he had the year before, exactly what he had the year before, which was 42,000. So that's the 42,000. But I don't want to write it because I want to show a pattern here. That's how much. But what did we multiply this by? Back to you. So after 2 years, what's his income? What he had before, the year before, you multiply it by what? Anybody? You multiply it by 1.06. So you multiply it again by 1.06. And well, how much he's going to be making after 2 years? If we this time that, this is going to give me the 40,000 times 1.06 to the power 2. So again, I'm multiplying by 1.06. So that's how much he will be making after 2 years. Okay, so what he made the previous year, I multiply by another 1.06, it gives me the 2. Now, after 3 years, how much he will be making? Now, that's his new income. 1 more year, I need to multiply by another 1.06. That means his new income is going to be, however he made the previous year, that's this red right here, but this has to be multiplied by another 1.06. So that's how much he made the previous year, but now he got another 6%. It means his new income is what he made the year before times 1.06. Now, if I add the exponent, how many 1.06 I have? I have 2 of them. I have another 1 of them. I'm going to have 3 of them. Okay. I don't know if you guys are seeing where I am heading. Anybody see where I'm heading? What do you think is going to be the formula after 4 years? I'm not computing because I need to build a pattern. What do you think you will make after 4 years? Can anybody see the pattern? Exactly, it's going to make that much to the power 4. So we can start seeing an exponential coming up. So in general, what's going to be the rule? After 2 years, so every year, from 1 year to another, his income is multiplied by 1.06, multiplied by 1.06, multiplied by 1.06. From every year to the others, his income is multiplied by 1.06. That's what we do every time. So the formula is going to be, after 2 years, is going to be 40,000 times 1.06 to the power t. And that's really where the exponential is really coming from. That's what's going to be the formula. So after 2 years, his income would be initial 1.06, that's the b in this case, to the power t. That's the formula for this kind of growth. So f of t in this particular scenario is going to be 40,000 times 1.06 to the power 3. That's a typical exponential function. So it represents a quantity which is increasing at the constant rate of 6% every year. Now, a little bit of the terminology. B in this case, that at the beginning we called it the growth factor. That's what we call the B. In this scenario is the 1.06. Now the reason it's called the growth factor is because every time we're multiplying by 1.06 from 1 year to the other, we multiply by 1.06 to get the new income. So the B is the growth factor, that's called 1.06. And the 6% raise that he got every year is called, this one is called the percent growth rate. And growth and its rate. And now I know that this is confusing because we're using the word growth in both scenario, The 6% is called the growth rate. And the 1.06, which is the 1 plus the 0.6, is called the growth factor. So before I start building the relationship between those two ideas, I'm going to give you one more scenario, and then we see what relate the growth factor and the growth rate. So the growth rate is by how much is the percent by which the money is growing. That's the growth rate. Every year it's growing by 6%. That's the growth rate. The growth factor is going to be basically 1.06. It means the 100% plus the 6%, which is basically 1 plus 0.06. So I'm going to build in a formula the relationship between them. But before I do that, I need to bring up another scenario to the picture. So, and then I can put the whole thing together. So scenario number 2, please ask questions as you move on. It's crucial you understand those ideas. All right, scenario number 2. I'm going to put the following scenario in front of you. Okay. So I'm going to call this scenario 2. All right. So let us say we have the following scenario. So I'm going to read it slowly in case you guys are writing. You can write it easy. In a certain town, the population was 20,000 in 2010. So just I made up numbers here. And is decreasing by 3% per year. So here we have a decay, all right? We don't have a growth, we have a decay. And P of T is the population T years after 2010. Question is, find P of 0 and P of 1. Okay. So what's P of 0? P of 0, P of T is the population T years. So P of 0 is the population 0 years, is the initial value is 20,000. Okay. What's P of 1? Okay, now I want you to give me P of 1, and we're going to do it in 2 ways in this problem like I did before. What is P of 1? All right, anybody else? Okay, Matt, how did you do it?
I did the 20,000 times 0.03 and got 600 and then subtracted 600 from 20,000.
Mm-hmm. So R is 3%. 3%, it means 3 over 100. Okay, 3 over 100 is 0.03. So that's the rate. So that's important to start. So let's see what Matt did. And as I said, I'm going to do this in 2 ways as well. All right. The first way is what your classmate did. Is the 20,000, right? And he took away 3% of it. Of 20,000. All right. So the 20 minus the 3%. And he plugged those things into a calculator, I imagine, and he got 19,400. Of course, we're losing 3% every year, right? So there is a decay, right? Now, how do you think I'm gonna do that in a different way? So what's the population over 1 year? And my question is, what percent of the population remain after 1 year? what percent remain after 1 year? So 97%, absolutely correct. Because what's happening after 1 year? The population is 20, it lost 3%. So what's actually remaining is 97% of what it is. So, or it is, you can think of it, so it's the 100% of the 20,000, but you're taking away 3% of it. What's left is, if you want, it's 97% of 20,000. So that's the population. But how can I find 97%? It means it's 0.97 times 20,000. Or it's 20,000, you multiply it by 0.97. So either you do this, which is correct, but since I want to build a pattern, what's the population after 1 year? And what every time this number is coming? It's the old population, 20,000, you multiply it by 0.97. Where is the 0.97 coming from? Where is this coming from? It reflects the 100% minus the 3%. So 0.97 is 97%. It means the 100%, you take away the 3% from it. So the 1.97 is actually the 1 minus 0.03. which represent 100 minus the 3%. That's where the 0.97 is coming from. Now, what's going to be, you think, who can build the formula for P of T? In general, what's going to be the population after T years? Can we have a formula for that? So what's the picture here? Let's see what the picture here. This is T, and this is the population. At 0, we had 20,000. After 1 year, we lost 3%. So what we still have is 97%. It means we multiplied by 0.97. That's really what we did. That's the picture here. So now we have 20,000 times 0.97. After 2 years, what's going to happen? My population decreased right now. After 2 years, if the same percent keep going, what I'm going to have here, I need to multiply again by 0.97. Because every year it's 97% of the year before. So it's going to be 20,000 0.97 to the power 2. Because every year we multiply what we had the year before by 0.97, because every year it's 97% of what it was. Every year is 97% of what it was. So what's going to be, you think, the formula? It's going to be, after T years, it's going to be, again, 20,000 multiplied by what? By the 0.97 to the power T. That's going to be the formula. If I want the population after 17 years, I can use this formula to figure this out. So in this scenario, the initial value, so that's a typical exponential. It's absolutely exponential. And the B is 0.97. That's the B in this case. And where is the 0.97 coming from? It's actually the 100% minus the 3%, which is the 1 minus 0.03. So that's B, which is we called the growth factor. Okay. Now, the growth rate in this case, I know that there are those two words that my goal is for you to understand today, actually. The growth rate here, rate, that's the rate here, is 3%, but I'm going to put a minus 3%. What is the minus coming from? The minus reflects the idea that we are decreasing. So even if it's written a growth rate, it's actually a decay, but that's the language of the book that I have to stick to it. But putting a minus here tells me that we are decreasing, we're not increasing. Does the formula have to be 0.97? No, the formula is 0.97, and that's crucial. Crucial, 0.97, okay? Absolutely. So now let me take both scenarios and see what's really happening here. So in scenario 1 versus scenario 2. So scenario 1, scenario 2. Okay. In the first scenario, we had initial population, initial salary was 40,000 and grow at the rate of 6%. That was my first scenario. And the formula was, so it means that the growth rate, the rate is 0.06. And the formula was 40,000 times, watch carefully, 1.06 to the power t. And then in the second scenario, my initial population was 20. The rate was minus 3%, minus is crucial, and the formula was 20,000 times 0.97 to the power t. Now, what's the relationship? I keep this empty. What's the relation? In the first scenario, the growth factor, it means the B, is 1.06. In this scenario, the growth factor, it means B is 0.97. So now, what's the relation between growth factor, it means the B, and the growth rate? Or the percent growth rate. All right, let's see what's the relationship. The growth factor is equal to okay. Anybody can figure out the relationship. Let's see in this case. What was the 1.06 coming from? What was this coming from? Is the 100% plus the 6%. So this 1.06 is actually 1 plus the 0.06, which is the rate. It's 1 plus the rate. Where is the 0.97 coming from? The 0.97 coming from is the following. It's the 100%. You took away the 3%. So this was the 1 minus the 3%. That's where the B is coming from. So in general, what's going to be the relationship between the growth factor and the growth rate? The relationship is that the growth factor, which is the B, is 1 plus the growth rate. Okay, that's the relationship between them. Now, but let's see, let me note something important, that if we have a growth, then the growth rate is positive. Like in the first scenario. If there is a decay, it means we are decreasing, growth rate is negative, and that's important. So in this scenario, the growth rate was positive. In this scenario, the growth rate is negative. So when I say 1 plus the growth rate, in the second scenario, the growth rate is minus 0.03. So I'm taking away the 0.03. One last thing, and then we'll practice it because it's once you get the ideas, it's not hard to practice those. So finally, one more word here. So important. Okay, then if f is a function, if f is a function, this function that increases / decreases at a constant % growth rate, which means you have a function like a population, income, money in the bank, where the money increases by the same % every year, 2%, 3%, 4%, then the formula is, an f is an exponential function, and it has the form a b to the power t, that's the formula. A is the initial value at 0, and b, which is the growth factor, is 1 plus the growth rate. And this number could be positive or negative, depending whether we have a growth or we have a decay. Okay. Now, in the last 10 minutes we have, I would like to practice those ideas with you. Can I move on? You guys ready?
No, I'm still copying.
Yeah. Done?
Yeah, you can move on.
Thank you. All right, so this is a worksheet that you guys have on Brightspace as usual. So I'm going to discuss it with you, and let's do it. Okay. So, and actually I will write the solution if you want and put it on Brightspace. But let us read the problem very, very carefully. A typical cup of coffee contains 100 milligrams of caffeine. I've just finished mine. And every hour, see, you don't have to write, this is on Brightspace. I just want you to listen so we can do it together. And every hour, 16% of the caffeine is eliminated. So you take this cup, you drink it, you drink the coffee, and of course the caffeine doesn't stay in you. Every hour, 16% of the caffeine is gone. So you start with 100, after 1 hour, you lose 16% of them. Another hour, you lose another 16% of what you had the hour before. Let f be the function that assigns to each time t the amount of caffeine in the body in milligrams, t hours after the coffee was consumed. Find a formula for f of t. So what's the scenario here? You start initially with 100 milligram, and every hour you lose 16%. So whatever you start with, I'm not going to make tables anymore because that's the point, is not to avoid those tables. So this is the time, and this is, so initially you start with 100. And every hour you're going to lose 16%. So every hour, what you have is, if you lost 16%, it means you have basically 84% of what you started with. That's really the idea. That's what's happening every hour. And the question is, find a formula for f of t. Right, how are we going to do that? First, f of t here is an exponential function. It means it's going to have the form a times b to the t. That's exponential. A is always the initial value, which is 100. Okay. B, now we have a decay, so 1 plus the growth rate. Okay. Now what's the growth rate in this problem? What's the growth rate in this problem? Can anybody tell me? Anyone? 0.8, no. No and no. It's not factor, it's the rate. The growth rate, it means by what percent is the amount of caffeine decreasing? By what percent? That's the rate. By what percent is decreasing by minus 16%. So that's the rate. The rate is by how much it is decreasing, which is minus 16 over 100, which is minus 0.60. That's the growth rate. The growth factor, which is the B, because you have to understand the difference between those two. The growth factor, which is the B, is 1 minus the 0.16, which is the 0.84. So the 0.84 is called the factor, not the rate. So this gives me that my function f of t equal 2. My initial value times 0.84 to the power t. And every time you write it, try to make sense out of it. It means after 1 year is 84%, which makes sense. That's really what this is, 0.84%. Now, how much caffeine is in the body after t hours? Sorry, after 5 hours. So now that I have a formula, okay, how much do I have after 5 hours? So how much caffeine is left? Of course, we lost a lot. We're losing 16% every hour. So after 5 hours, I'm going to have 100 times 0.84 to the power 5. And the number is absolutely decreasing because we're losing the 5%. So I don't know how much we get. 84 to the power 5. I don't know how. I'm getting 41.82 milligrams. Of course, it's decreasing. We're losing caffeine. How much we're losing is 41.82 milligrams. Okay, very crucial, very useful type of functions because they really reflect this kind of behavior, something that decreases by the same percent. All right. Okay, number 2. A town has a population of 7,000 in the year 2005. Why I'm going to decreasing both time, I don't know. And it's decreasing. So when I read decreasing, I basically, sorry, it's missing the D, the E here. At a rate of 1.5% per year. Let f of t be the population t years after 2005. Find a formula for f of t. Okay, I'm gonna give you a minute to give me the formula. All of you, and then we go over it. I wanna make sure you can do that. So decrease by the same percent, that's exponential type function. Each one of you trust yourself and do it, because if you do any mistake, we'll have to address it now. Every student to find the formula, please put it on chat. We'll take 2 more minutes, so please stick around for only 2 more minutes. I apologize for that, but I want to make sure you can do it before I let you go. Okay. You forgot the T. Anybody got anything close to the person that on bright space? I mean, he forgot to put the T, but that's okay. So I will do it. We need the formula. So here, that's an exponential. It means whenever the function decreases at the same percent rate, the formula will have the following form: A times B to the T. And our job is to find each piece of them, the A and the B. The A is always easy. It's the initial value, which is 7,000. The B is 1 plus the growth rate. So to find the formula, I need to find the growth rate. So what's the growth rate here? It's decreasing. It's a minus 1.5%. Now, 1.5% is 1.5 divided by 100. So you just divide by 100. And this will give me minus 0.015. That's not the B. That's not the B. Your B, it means we're losing 1.5%. The B is what's left after we do that. It's 1 minus 0.015. It means 0.985. It has to be less than 1 because it's less than every year. It's not 100%. It's less than 100% of what it was the year before. So every year is 98.5% of what it was the year before. So this will give me that my function f of t is, and now I put it here, A, which is the initial, times to the power t, because that's f of t, and this is 0.985. This B, this is called the growth factor, not the rate. This is what we call the growth factor. All right. I have to stop right now. Before we go, remember that next Thursday is your second exam. So exam 2 is next Thursday. Okay. I will, as usual, I'm going to write a review, most probably tonight. And I will send each one of you an email telling you that the review is on Brightspace. And please, this material will be on the exam. I think it's not too hard. So please, for Tuesday, do the homework, the practice problem, and also please work on the review. And I will review with you on Tuesday. And finish your online homework. It's due tonight. And there will be no online homework for next week. Next week, I want you to start reviewing. Okay. Right. Any questions?